on-off task, and this is all triggered with this plain Java code. With some lines of code here. It's very simple. I think here below this just for persistency. Let's have a look at the rules. I think we have made it a bit different in terms of creating the modes. I think almost everyone, I guess, creates the modes at first, at least after the configuration has been created. We decided to do a little bit more modular way. We implemented a conditional unit, a transformation unit. I just say transformation unit, which gets a name and which looks for a mode with the given name, and if the mode exists, it is returned as a parameter, and if it does not exist, it is created and returned. And with this getMode transformation unit, we are able to reuse this functionality and create the modes if they are used, if they are needed. And so far for that. The whole algorithm is quite simple. I think it's just three sorts of loops which translate certain patterns in the specification file to a certain pattern in the configuration file. The first one is the observe button loop. So we just have a look at the corresponding pattern, and if there exists something like this, the corresponding mode is getted or created, and in this case the buttons are created. And here, this is a special case. This is an amalgamation unit. I mentioned it yesterday already. Here, the then part and the then part in the source model and the corresponding mode in the target model are put in a kernel node. That means that it's matched once, and all observed button occurrences are matched all together as often as possible, and for each one the corresponding button in the here in the right hand side is created. And in addition, with our trace object, we also remember the position statement in this observe button. Here's the name and the position, and the name is set here in the button, and the position is just remember. That the next part, the enters model loop, it's almost very similar. It's just a loop and a sequence of rules and units. First, it's have been looked after such a pattern, and for each of these patterns, the corresponding mode is created, and the corresponding string constant as well. This is even similar to the get mode. Maybe we can call it function or method. Here, this string content is created or getted as well, and in the last part, the mode and the string constant are some sort of connected here with the change display object. Okay, the last part is the press button loop. Here I have to say that our approach is uses the set semantics due to its underlying formalism to graphs and graph transformation, and such that we have no construct for ordered lists as in EMF, such that we cannot exactly determine that the next statement really refers to the next in the what has been mentioned in the source model. But we give the best, and that's why we use the trace model, not the trace model, the trace object. Here we have the position, and with the name and the position marked here, we are able to determine the correct button to have at least the next mode in it. I think model refactoring would be very, very helpful in this case, where the next really refers to the next button and not just say it's the next in the list. Yeah, well, that's by intention, as I heard. So, yeah, that's it mainly. Here we have a conf parameter, and this is exactly this parameter holding the configuration object, in which is the root to be persisted on the Java code. And that's it.
Can you run the transformation?
Yeah, of course. Just have here another indirection there. And this is the result. This is exactly one-to-one the given example. No, just in time.
So, are there any questions?
How far did you get with set time?
Pardon?
How far did you get with set time?
Not far.
So just the first one.
Exactly. But it wasn't a matter of our tool, I guess, and just a matter of my brain. I really have some problems to understand the case scenario, and I guess that's the main reason.
You're loud now.
Pardon?
You're loud now.
Thank you.
Any other questions? No? Then thank you.